Welcome everyone to our today's session. So in this session we are going to discuss about the power generation using the renewable energy source of solar. So the solar power generation systems use mirrors to collect sunlight and produce steam by solar heat and to drive the turbines for generating the power, which are clubbed to coupled to the generator. So the generator will generate the electricity using the prime mover. The system generates power by rotating turbines which are available in the thermal and the nuclear power plants, and therefore it is suitable for large scale power generation, right? This system, that is this solar power plants, use the heat energy from the sun's radiation for converting the water into steam, and the steam will be used to run the turbines, which are clubbed to the generators, which will generate the electricity. So normal thermal power plants will work on this principle, where the heat is derived from burning some fuels like coal or oil. So instead of using or burning the fuel, now we are getting the heat energy from sun. So the sun's heat is utilized to convert, or for getting the heat, for converting the water into steam. So the solar power generation can be carried out in two ways. That is, we can directly convert the sun's radiation into electricity, that is using photovoltaic cells like in arrays, which will convert the sunlight directly into electricity. So that is one method of producing the electricity. In the other one, the concentrating solar thermal power station, CST, right? So this will generate electricity by converging or concentrating the solar radiation onto a single axis or single point, whereby the axis will be having some working fluid flowing into the through that axis. So the cold fluid will get heated and it will become its vapor, and this high pressure vapor and high temperature vapor will be used to run the turbine for generating the electricity. So what are the types of, or how the solar collectors are classified? So one is non-concentrating type and another one is the concentrating type. In the non-concentrating type, so the best example is the flat plate collector. So the flat plate collector, either it can be a liquid flat plate collector or a hair eating flat plate collector. In the concentrating type, we will be having focus type. So focus type is, there are two types. If it is in line focus, that is having only one axis tracking, that is the parabolic concentrators are coming under this category. So this line focus types are having three types. One is cylindrical parabolic concentrator, and second one fixed mirror solar concentrator, and third one is linear Fresnel lens concentrator. So all these concentrators will concentrate the sun's radiation into or onto one single axis, right? So this concentrators, that is the collectors, have to be moved such that it will always track the sun's path. So then only we will be getting continuous sun's rays falling on it, reflected to one single axis. Another one is the point focus type, whereas we have the hemispherical bubble mirror concentrator and circular Fresnel lens concentrator or parabolic disc collector or central tower receiver. So all these are coming under point focus type. And there are also non-focus type collectors are there. What are these? Those? One is the modified flat plate collector, and the other one is the compound parabolic concentrator. Again, the solar thermal power systems can be classified into passive and active. So what is passive? A passive system requires no equipment, so there is no movement, right? So there is no movement of any equipment or any parts. So like when heat builds up in any one container, so it is simply is getting heated. So the heat is added without any moving parts or additional equipment. So the best example is this thermal chimneys. And another uh, type is the active systems. The active systems requires some way to absorb and collect the solar radiation, and then it will store it for some time. So best example is our solar thermal power plants. Let us see the basic working principle of a solar power plant. Here the sun's radiations are collected by using the mirrors. The mirrors reflect and concentrate the sunlight and onto the material which will be used to change the space. The receiver collects that solar energy and converted it into heat energy. This heat energy can be used to convert the fluid phase. That is, if we are taking the molten salt as our working medium, this molten salt will be getting it heated, and this heat will be stored in the high temperature molten salt, and this heat can be utilized using in heat exchanger to heat the water and make it into steam. So this heated steam, converted steam from water, will be used to run the turbines, and the turbine will be coupled to the generators which will generate the electricity. So this is the basic principle how the electrical energy is generated using the sun's radiation or sun solar radiation, right? So this is an indirect method of generating the electricity. So where we are using the heat to convert it into the other forms, right? So we are not directly generating the electricity like in the PV cell. In the PV cell, we are getting electricity by direct conversion of the electrical energy into electricity. So this solar power plants working indirect method. So these are all the type of, let us see some type of the solar thermal power plants which are using the parabolic trough system. So we can see that the concentrating mirror are in the shape of a parabolic trough which will concentrate on the radiation into a single axis. So on that axis we will be having the fluid flowing. So the cold fluid entering in one end will be getting heated by the reflected sun's rays, and it will come out as the hot fluid in the other end. So this is a parabolic trough system. Based on the profile, we are naming it as parabolic trough system. So in other systems, like in the solar power tower systems, a tower will be used for storing, at the top of the tower will be storing the fluid, and whereby the fluid will get heated by reflecting the sun's rays by using many number of flat plate collectors. So the mirrors will reflect the sun's rays onto a single point where this medium is stored. So this medium will be getting heated, and this heated high temperature will be used to generate or exchange its heat to some other fluid for getting it phase change. In other types, the solar disk or engine system, the solar disk will concentrate the total or the power onto a engine, a heat engine, which will generate the power, the mechanical power. Like using a Stirling engine which uses the heat will generate mechanical power. So that kind of Stirling engine can also be used at the concentrating point, and the collected heat will be transferred into the other mechanical form. So we have the other compact linear Fresnel reflectors will be like a small pieces of linear flat plate collectors which will be arranged in such a type. It will concentrate the reflected radiation into one single axis, right? So that is called the compact linear Fresnel reflectors. So all these reflectors are named, the process systems are named according to their profiles. The parabolic trough system, as we have already seen in the image, is consists of a linear parabolic reflector that concentrates light fluid. Entrance, the working in a low temperature, but when it is coming out, getting heated, and will come out as the reflectors follow the sun's position during the daylight hours, and the collectors are tracked using some tracking system. So this parabolic collectors or reflectors uses a single axis tracking system. The working fluid will be getting heated from 150 degree to 350 degree centigrade, and when it flows through the receiver, and then again it is used for power generation system. So this is the general layout we can see in the figure in this monitor. So we can see that there are a lot of parabolic trough systems are combined together, where the blue lines are the cold fluid entering, and when it comes to the other end, so like this here, so we can see that, so the blue lines, so here the cold fluid is entering and the sun's rays are reflected on this axis. So this cold fluid will get heated up and it will come out as hot fluid, and this hot fluid energy will be used to exchange to another medium like water. So it will transfer its heat to the water to convert this water into steam, and this steam will be used in turbine for converting its gained energy uh, into mechanical energy. So when the turbine is clubbed to the generator, which will generate the electricity. So the cold fluid coming out of the turbine, that is the low temperature, low pressure fluid coming out of that turbine, can be cooled again using some condensers, and again it will, the phase will change into steam to water, and this working fluid again can be used in a cycle. So this condenser will get its cold water from the cooling tower, just like in a thermal power plants. So this is the working principle of a solar thermal power plant which uses a parabolic trough system. So this is an image of the parabolic trough system. It's in the original installed at some point. So where we can see the axis is fitted with the tube through which the working fluid is flowing, and the sun's rays are collected and it is concentrated on this axis to heat the medium. So the solar power tower system, the power tower, also known as the central tower or the heliostat power plant. These designs capture and focus the sun's thermal energy with thousands of tracking mirrors called the heliostat. It is roughly into a 2 square mile field, all the energy is captured and reflected to one single point on the above the tower, which is called the central tower. The tower resides in the center of the heliostat field. So the heliostat focuses this concentrated sunlight onto a receiver which sits on the top of the tower. So the receiver, which will contain the working medium, will get concentrated, and the sunlight heats the molten salt. Mostly the molten salt is stored in the top of the tower. So this molten salt will get heated up to 530 degrees, then flows to the thermal storage tank where it is stored, and it can be maintained 90% of its efficiency, and eventually pumped into a steam generator for exchanging its steam. Right. So the steam then drives the standard turbine to generate the electricity. So during the cold time, so the non lighting day, so the heated fluid will get cold and it will again pump to the top of the tower. So this is the layout of the tower solar power plants. So at the top of the tower we are having the molten salt stored, and it will be getting the heat reflected by the mirrors, flat plate mirrors, which are concentrating on the single point, and this concentrated power will get heated the molten salt. This heated molten salt will be stored into the storage, and it will be pumped to the heat exchanger where it converts or exchange its heat to convert the water into steam, and the steam will be used in the steam turbine to run the or generate the electricity. So again the steam coming out from the turbines can be cooled down to water medium again by using in a condenser. So this is the original image of a solar power tower system where the number of heliostats, the reflectors, are positioned like that, such that the sun's rays are concentrating on the top of the tower where the molten salt is stored and it gets heated. So this is the image in one of the solar power tower systems. Again, as we already seen that the solar disk engine system, the solar disk type is used to concentrate the light onto a receiver positioned at the focal point, and this working fluid which is received will get heated to 250 degree to 700 degree centigrade, and then it is used by the Stirling engine to generate the power. So normally the Stirling engines are used in this type of systems for generating the power. So either the engines can be installed at the focal point, or again some storage, a water storage or some working fluid medium can also be stored at the focal point to receive the heat energy. Here the engine type systems are used for generating power using the engine, which is nothing but a heat engine which receives its heat by the solar. So this is the arrangement of a solar disk collector which focuses all the fallen energy onto a single focal point, and at the focal point a Stirling engine is installed for the functioning. So this is an original image of a number of disk type solar collectors fitted with engine. So again the another type of reflectors are called the compact linear Fresnel reflectors. So the linear Fresnel reflectors use long thin segments of mirrors to focus the sunlight onto a fixed absorber located at a common focal point of the reflector. So these mirrors are capable of concentrating the sun's energy to approximately 30 times its normal intensity. So this concentrated energy is transferred through the absorber into some thermal fluid. So the fluid then goes through the heat exchanger to produce the steam if it is the working medium is the water. So the steam again goes to the steam generator for generating the electricity. So this is the arrangement of the linear Fresnel reflectors, where the reflectors are arranged at the bottom side of the tower, that is the axis, where the fluid flows through the pipes. The fluid enters the blue color line, shows the cold fluid is entering the tubes, which gets heat by the reflected sun rays by the Fresnel mirrors. So it will come out at the other end as a hot fluid, which is shown as in the red color. So the red color shown is nothing but the water is converted into steam. The steam again can go to the turbine, and the turbine is coupled with the generator into the grid. So this is the layout of a general linear Fresnel reflectors employed in a tower solar system. So we can see the original image like this. So we can see at the bottom. So many number of plates, linear plates are arranged such that all the reflected sun's rays will concentrate on the single axis, and the single axis is provided with the passage for the tube medium flow. So this is an original image. So again, another one is the enclosed parabolic trough. The enclosed parabolic trough solar thermal system encapsulates the components within the greenhouse gas. So that is the greenhouse gas. The greenhouse protects the components from the elements that can negatively impact systems reliability and the efficiency. The lightweight curved solar reflecting mirrors are suspended from the ceiling of the glass house by wires. So it is not fitted at the ground level, so it will be suspended by some wires from the ceiling. A single axis tracking system positions the mirrors to retrieve and receive the optimal amount of sunlight received. So the mirror concentrates the sunlight and focuses on the network of the all suspended from the glasshouse structure. Water is pumped through the pipes and it gets boiled to generate the steam, and when it comes with intense sun radiation, and it goes through the steam turbine to generate the power. So this is an image, a real image of the enclosed parabolic trough power system. So let us see some advantages of the solar thermal energy. So where we have no fuel cost, which is because the solar energy is abundantly available at free of cost. So there is no fuel cost, and it is predictable. So on all long sunny days, so 24/7, the power can be stored and can be used for the power conversion, and it will generate no pollution and no global warming effects. So it is using existing industrial base, so that the dependency on the fossil fuel is reduced. Some disadvantages can be seen from the solar system. The initial setup cost will be high, and so the systems or the technology are under experimental or so the future technology has a high probability of making it obsolete. And the another one is the ecological are there while using the solar thermal system. So it can be only in the possible sun's receiving area. So only limited locations and site limitations are there. So that is why it is a limited possibilities are there to convert the sun's energy into other forms of energy. So these are all some of the disadvantages. So even though, so there are disadvantages, as we have more advantages are there, the technology is getting widely accepted and it is going to be used by the entire world. What are the major challenges in using the solar energy? The major challenges are the installation cost and the energy storage. So the energy storage means we cannot store solar energy directly as it is, but the energy received converted from the solar energy can be stored, so like electricity, and can be used so whenever it is required. So the costs are still far higher than the fossil fuel plants based on the units of energy produced. So if some improvement are there, so we can expect some the operating cost will be somewhere come down. The hot water storage products are often stretched to their limits, and alternatives could be phase change materials or thermochemical materials, or can be used for converting the or storing the heat, or converting the heat into the other forms. So in addition to the sensible heat, the technologies of latent heat and the thermochemical energy storage are on the way to become very promising solutions for the future of the solar and heating and cooling. So some of the quickly we'll see the applications of the solar application. So we can use the solar for heating the water and the air in like the solar water and the air heating system. The energy can be used to pump the water in solar pumping, or it can be used to produce heat energy for cooking food materials in the solar cooking. So we can in this screen we can see a solar cooker, which is there are two types. For household cooking, a box type solar cooker is used, and for community cooking, a concentrating type, which is a little bit bigger than the box type, will be used for making the food products. So these are some of the examples of using the solar energy for heating the water. So the water will be heated by getting the energy from the sun. So to conclude, in the face of the global warming, rising fuel cost, and an ever-growing demand for energy, the energy needs are expected to increase by nearly the equivalent of 335 million barrels of oil per day. So mostly for the electricity production. So this much of fossil fuel are not promising us in the future. So we have to find some other alternative. So which is best one is our solar energy. By utilizing the solar energy, we can reduce the dependency on this kind of oil or some other solid fuels. By concentrating the solar energy with reflective materials and converting it into electricity, modern solar thermal power plants, if adopted today as an indispensable part of energy generation, may be capable of sourcing electricity to more than 100 million people in the next 20 years. So we can see all from one big renewable source, which is the sun. So if you are using the sun's energy effectively and correctly, we can improve the power generation technology with almost with no cost. So thank you for joining this session.